we can determine everything. It's very complicated, random access, things that it does, it measures disk speed and spindles, all these kind of things to be as fast as it can on disk. A lot of the NoSQL stores completely hunt here and just say, you know what, I'm going to make my on-disk representation as simple as possible. I'm just going to do append-only style writes, and when I do reads, I'm going to keep an index in memory. I know where that thing lives. I'm going to do a seek, I'm going to do a read, and then I'm done. I'm going to rely more on the operating system to help me cache all this stuff to make it more efficient. So development stuff, a lot of that we talked about, multi-platform support. A lot of the NoSQL data stores, because of where they kind of grew up and people develop them, tend to be much more focused on Unix and Linux. To a little bit lesser extent, Mac, there's a lot of good Mac support, but not as much on the Windows platform. I don't mean that as a slam, I'm just saying that's where a lot of development is going. Commercial support. A lot of times that's a huge thing, especially when the company wants strong commercial support. Of course, with RDBMSs, the vendors would love to study support on third parties. We don't ask anything to that. On the NoSQL side, it just depends on the project. Some of them are actually commercial projects that have an open source counterpart or are commercial. Some of them are completely open source. And so you have whatever resources are available from user groups or use groups and different things like that. So that's a huge consideration. And then on the tool support, again, we have all kinds of tools that we work with day in and day out. On the NoSQL side, tends to be not a lot of strong tool support. Again, that's one of those things that's changing as this technology matures and time goes on. So detail. So now we're going to kind of talk about the breakdown of these four groups. Some of the specifics about what they're designed for, what they're good at, what they do, what they look like, and then on the next slide we'll present some specific products in that space. So, column stores. So these databases are going to look, at least on the surface, they look a lot like the relational databases that we work with all the time. But they tend not to really be relational. For example, Google's Big Table, which was one of the original implementations, was a really good paper out there in 2006. If you're interested in stuff at all, that's one of the good places to start. It's called Big Table, and that's what it is a big table. You can have tens or hundreds of thousands of columns, by hundreds of millions and billions of rows. And it stores the data in a column format, so basically a big hash. And it knows how to distribute that stuff, break the hashes up and distribute them over Hadoop in particular, which is another product, well, HBase, whatever it is. But it'll scale to thousands of nodes. And this is what Google uses internally to do a lot of magic that they do. Schema-less, it's actually probably more proper to call it more schema-relaxed. It has a concept of what it calls a super column or column family, which is basically a grouping of columns. There's a certain technical reason why they do that. But the columns under a particular family, you can have as many or as few as you want. You can have them as you want. And some of the interesting effects is your information in any particular column tends to be much more similar than the column across the row, especially if you've got a lot of rows. And so they can take and compress by rows. Compress by column. And if you have 10,000 columns on any particular row, you're probably not doing updating all 10,000, maybe only updating a handful. And so the way they store the information is null values are essentially free. The null cells are essentially free to store. So it can be very efficient to store this information. But one of the big differences here to understand is because the data is being stored on disk in a certain way across the columns, is it tends to be more difficult to do row-style updates. So it tends not to be as good at transactional types of things like we do on the web or a lot of applications. It tends to be much better for data warehousing style applications where you have just a level of information and you want to be able to very efficiently pour over all that information in a very fast way, very distributed, very parallel way, and pop out some kind of answer that's meaningful to you. So some of the products in the space, we have Bigtable, which is Google. So again, there's a great paper out there written in 2006. You can Google for Google's paper, and it's got an excellent background, a lot of good information. It's actually only about 10 or 12 pages, I think. It's fairly short and not super technical, so it should be able to get through it pretty easily. Hadoop or HBase. Hadoop is a little bit different of a product. It's part of the Apache group, and Hadoop is a name kind of for this ecosystem that's out on Apache. There's probably 2 or 3 dozen different projects that form part of Hadoop, this big project. It's also the name, what they call the MapReduce project. But underlying it, instead of what they decided to do with this project, instead of taking this database and making it distributed, they made a distributed file system instead called HDFS. And then we're going to store a bunch of stuff in a distributed way on the file system. And then from there, you can build up additional layers. And one of those layers is HBase. So it's a column store that sits on top of this distributed file system. Super popular. There's commercial support. There's huge communities. There's dozens of projects that are part of this. There's just a lot of really good stuff. First was talking about U-Hub here, the Hadoop user groups that are coming out as a result. It's very popular. Cassandra, which was developed by Facebook, I believe, and it's Java-based. And one of the very interesting systems, they have NAM and NAM replication out of the box. And so that could be something very, very important for you. If you've got distributed data centers, here's a product that kind of covers replication out of the box. One company I worked for before, we tried to use some of this as Oracle, and it was possible, but boy, was it hard, and it was, of course, very expensive to do for. And you can never get it quite perfect. It was never real time. Of course, you're talking across the pond, it's never real time. Hypertable, which uses a pluggable distributed file system, so there's a field in there that you can plug it. Vertic is actually quite interesting. It's one of the commercial products in this space. There's a paper called C-Store, C-Store, where they talk, started out in academic paper, and then eventually just worked into a commercial product that HP now owns. And one of the very interesting things about it is how the full SQL implementation on top of it with this column store underneath. So all of your, not sure if all, but many of your business intelligence tools will work on this out of the box. A lot of the other SQL tools that we're used to working with it out of the box. So it kind of crosses that gap, and that's one of the things that makes it interesting. And then, of course, on the top, we have Amazon SimpleDB, which we can go out and play with and not have to install. Amazon do something else before. So document stores. There's a lot of products in this space in particular. Actually, in general, there's a lot of products that are covering that. Again, here, at some point, there's going to be a lot of consolidation with these, depending on who's popular. So a lot of these have very good cap tunings, so you can actually store data in a lot of these data stores in multiple ways by tuning different segments of it. It can handle multiple tunings on different data sets, which is quite interesting. Basically, key value stores, several of them will have a bucket in front of it. For example, Amazon S3 gives you a bucket for key and value. The bucket generally is for namespacing or namespace considerations to kind of separate, to get a better way to separate these out. A lot of times there's different parameters with different properties you can put on a bucket that kind of controls data underneath it all. Sharding is pretty easy. It's just hashes. It's pretty easy to get this stuff to buy it and work really well. So usually ACID compliant, but again, that's for a single commit. It's not like multiple commits. NoSQL doesn't really apply here. It's hard to run SQL across the hash. You get parts of it. Pretty easy to implement. Again, it's a hash. You know how to use those. Those are pretty everyday stuff for us. So there actually is at least one project now, but I know as part of